Okay, I know we have some waifs and strays gradually coming in, so we'll just leave the door open. Um, is this our first seminar of the year after the symposium? I think yes, this first science seminar. And it's my huge pleasure to invite a very long-term Archibald colleague, Paul Gray, to give today's seminar. And I'm going to take, it's not normal I do this, but I'm going to take a few minutes to sing his praises. He's been a great colleague for Archibald for decades and is a strong personal colleague for me. So I'm just going to tell you a little bit about Paul. He is the Everglades Science Coordinator. So he works for Audubon of Florida, and he deals with water quality, water management, ag best management practices, ecosystem and bird conservation, primarily headwaters of the Everglades, watershed of Lake Okeechobee. So he person just down the road for us, working in the same environment as us. Before he started working for Audubon, he did his graduate work. I'll talk about that in a minute. And then he started with the Fish and Wildlife Conservation Commission, began with Audubon, Florida, and he started off in a place that was known at that time as the Kissimmee Prairie Sanctuary, which eventually got what's the right word? Absorbed, transferred over, over to the state park, Kissimmee Prairie State Park. Oh, I should stand here. Okay, thank you very much. Hello, everybody. Yeah. One of the things about this watershed is you have to deal with private landowners as well as public landowners. So Paul's taken a big leadership role in that. And, you know, he's focused on habitat connectivity between private and public lands. And he's tackled a lot of bird conservation issues on private and public lands throughout the watershed. As with many other Archibald staff, he's a member of the Florida Grasshopper Sparrow Working Group and has been instrumental in the sort of gradual recovery from the bottom of the trough for that species. Definitely relevant for our Avon Park folks who are here today. Yes, I saw them. Yes, thank you for being here. And he's co-chair of the Snail Kite Coordinating Committee, another bird that is actually, are you still there? We got out of it. Well, I'll rephrase that. He was the co-chair for the Snail Kite Coordinating Committee, another species that has actually, you know, gradually bounced up. Paul got his bachelor's from the University of Missouri, and then a master's from Texas Tech, and then a PhD from the University of Florida. I have to say, we are both originally waterfowl biologists, almost the same time, graduated almost at the same time. So that's always in common for both of us. And he did his biology on Florida's mottled ducks, and actually on the region in this area, Lake Okeechobee and around. And when I went and looked at the acknowledgements, it was very sweet to me to see that he was acknowledging all the ranchers that allowed him onto his land, many of whom we still work with, one of whom is actually on our board. So Flying Bee Ranch, Flying G Ranch, Woody Lawson, Lawson Dairies, Jeff Clemens, Pierce family, they all worked with you. And according to you, they all towed you out of mud holes, for which you are very grateful. Those of us at Archibald will recognize the important role of this. Although Paul always says in any meeting, I'm not a practicing scientist. And for those of you who are coming up through Archibald and beginning your careers, he has a very sound grounding in science, but a lot of his reports are really important. If you go on the Audubon website, there's a long list of technical reports that he has written, and they're actually legible, readable. He did publish earlier papers. I was quite surprised. Papers on subcutaneous mites, a redescription of the belted kingfisher, helminth communities in waterfowl species, things I didn't know he'd done before. But the papers that he produces, the technical reports, go and look at them. You know, the improved outlook for the Florida grasshopper sparrow, Audubon's new mapping for protecting Orlando water resources, fixing Lake Okeechobee and estuarine discharges, something he's going to talk about today, I'm pretty sure. Improving critical habitat for snail kites. These are important papers that conservationists groups read, state agencies read, and do not underestimate the role of a really well-written technical report for changing policy and funding, for which we owe Paul a huge debt of gratitude. Paul's got to that lovely stage in life where he's getting lots of awards. I'll just name a few of them. He's a very humble person, but I don't want to miss this out. So first award, in 2021, he was the Florida Wildlife Federation Environmental Stewardship Award, which was, he said in a very humble way afterwards, this is really a recognition for all the organizations I worked with who really helped me protect Florida's resources. He got an award from the US Fish and Wildlife Service, where there was also other Archibald staff, including Reed Bowman, which was the award that Team Sparrow got for helping to recover the Florida grasshopper sparrow, well, helping to move that recovery. And that was in 2019 to 2020, the Regional Director's Honor Award for Team Sparrow. The next one that was actually present for. I got a few calls, and Paul, this is an unusual category, was recognized as the conservation friend for the Florida Cattlemen's Association in 2019. He doesn't put it on his resume, but he is actually a cattleman. He owns a small herd of cows and owns a lovely property just to the north and west of here, with a beautiful wetland in the minute. But he was primarily recognized for his role in working with the ranching community, adding to the network of conservation lands, and really understanding the role of private landowners when addressing water and conservation issues. A couple of other notable ones, I could go on. He got the Everglades Coalition, John Casher, I think it's John Cabler Award, which is a sort of grassroots award. And then in 2021, he was awarded National Audubon's highest award for a staff member, the Charles Callison Award for work in the Okeechobee Basin. Like what his boss said at the time, Paul is one of the really lucky people where he says, I'm my own boss and I don't have anyone else underneath me. So it's a lovely role, but he does have a boss. Julie Raithmate said about him, Dr. Gray's expertise is matched only by his skill in engaging diverse audiences. He moves fluidly, interesting word, from testifying at a podium to driving an airport. He drives a wonderful airport and has taken many of us on tours of Okeechobee. So if you ever get the offer, just say yes. To slogging barefoot, I have seen many pictures of Paul looking barefoot and gleefully through the wetlands of Central Florida. He makes mountains of dense hydrological data accessible and even elegant for audiences ranging from decision makers and ranchers. I hope that's going to happen today. Finally, I wanted to end with the fact that Paul has made a huge difference to Archibald. He's been one of our conservation and science colleagues for years, for decades, since he started working this watershed. If Betsy and I want to know some policy or history of the watershed, we always rely on Paul. He's been fundamental to a lot of our work at Avon Park, a lot of our work on listed species. You should also know he's been a very generous donor to Archibald for several years. Thank you, Paul. He's a participant in our Christmas bird count. And one of the things I really love about Paul and Archibald's connection is when he's ever getting an award, he always uses one of Dustin's wonderful photos of him at Istapoga as his go-to photo for an award. So I'm sorry that went a long time, but you're a very special person for Archibald. You've been a dear colleague and friend of mine, and we love working with you. And we're looking forward to your talk, which has got the title there, Science and Policy of Everglades Restoration. And I'm sorry I went on a bit, but I don't usually do this, but you're really special. Thank you. Over to you, Paul. Yeah.
Good. Thank you. Well, I'm glad that's over. Hillary left out some things. She and I were both born the same month, the same year, and I am her senior. And we both started working in our respective positions in 1995. So our careers have been pretty parallel. Okay, so thanks for having me. I'm Paul Gray. I work for Audubon, Florida. Of course, we're a bird conservation group. As Hillary mentioned, I'm going to talk about this today. I am a trained scientist, but I work for our policy team. I don't work for our science team. And that's been a big adjustment because they're very different culture than we are. And where scientists try to explain, here's what I think, but I can't prove it because you can only disprove hypotheses. And there's 27 caveats. And the policy people are like, just tell me what you want and I'll go get it, you know? And so it's been hard to learn that culture. And so this talk that I developed today is a novel talk. I've never given it before. I kind of put it together for you guys to kind of talk about some of the issues that are going on and what we're trying to do about it and try to help you see what my role is working with policy people and what is going on in this watershed. And the title is Everglades Restoration Work, but as Hillary said, this is going to be mostly Northern Everglades. I'll talk a little bit about the Southern Everglades, but mostly I'm going to talk about our work in this watershed. And I'm going to start it off with birds and the history of Audubon, and as kind of an example of how to understand how hard this work can be.
Oh, yeah. So move your screen. Yeah, now try the Okay, we need you, Laura.
It was working a little while ago.
I know.
The content of this meeting has been sent to a third party.
That's got it.
The audio is getting a great cameo.
Are you using left and right?
Yeah. Okay. I'm moving the mouse again. It might be more reasons. Sorry, everyone.
There we are. There we are. Okay. If you've ever seen my talks, I always start off with this. This is me, 1938. My name is Marvin Chandler. I'm the very first Audubon warden on Lake Okeechobee. And I'll get back to Marvin, but you notice he's got two belt buckles, and one is actually a badge. And this was back in a time when FWC didn't have a big law enforcement division. And so Audubon would hire people, the state and feds would deputize them, and they'd go out and enforce laws. And he was on Okeechobee looking at glossy ibises because back in the 30s, 95% of all the nesting glossy ibises in the state were on Kings Bar on Lake Okeechobee that we knew of. And anyway, they're coming back and they couldn't get around this thing, which is, it's a water moccasin, 5'11". And in its stomach, they couldn't get around it on the trail, but in its stomach, they had a glossy ibis egg, 3 tricolored heron eggs, another digested egg, a baby American egret, and an adult glossy ibis. So if you find water moccasins, they're fun to play with. Okay, so I'm going to start with kind of a history of how Audubon got formed. And part of this is to try to tell a story about how long it takes to make changes. And of course, back in the late 1800s, that was a big period of ornithology, and everybody was out shooting and describing birds and having 7 different varieties of every single bird. And it was an age of hypertaxonomy in this. So this is Ridgway's Manual of North American Birds. This book is like 4 inches thick, and it just has page after page after page of this kind of detail on birds. And of course, to get that, you have to shoot the bird. Okay, so this is one of the taxonomists of the day, William Earl Dodge Scott, W.E.D. Scott, 1876, Lake Panasoffkee. He shot 40 snail kites on that trip. And these are actually some skins of his. This is from a history display. And Scott was one of the very first ornithologists to describe the wading birds in Florida. And I'll tell you a story about him. Frank Chapman was a very prominent ornithologist. What famous count did he start? Christmas bird count. Yeah. So he's the one that started it. But this is his handbook of birds. And so if you think about, taking the field guide out with you and you want to identify a bird, can you see that? Bang. So they were doing bird watching by shooting birds and then keying them out. And this is Joseph Batty. And I just about died when I found this picture. This is courtesy of the American Museum of Natural History where Chapman worked. And this is a real person. Obviously, he's posed kind of goofy, but he and W.E.D. Scott had an interesting story. Joseph Batty grew up in the New England area. He did taxidermy. He worked in the plume business. He wrote this wonderful book, Practical Taxidermy and Home Decoration. And he wrote in there, Yeah, he wrote in there, and it's a whole book about how to shoot birds and skin them and prepare mammal skins and stuff. And he wrote, what in this age of increasing wealth, this is the industrial age and post Civil War. What fireplace mantle doesn't look better with a pair of mounted Baltimore Orioles on? And it's all full of what kind of guns to shoot, what kind of shot, and even if you're going to spend the winter somewhere collecting specimens, you got to have a woodlot of at least 2 acres to have your firewood last. And just a really amazing book. And during the Civil War, he actually sold powder horns. So this is from Chapman's Handbook of the Birds, and this was written in late 1890s, and he writes, the curse of beauty. This is a description of the species. The curse of beauty has numbered the days of this most dainty and graceful of herons. 20 years ago, it was abundant in the South. Now it is the rarest of its family. 1895. The delicate aigrettes which adorned his nuptial dress were its death warrant. Woman demanded from the bird its wedding plumes, and man has supplied the demand. Florida herons have gone, and now he is pursuing the helpless birds of the uttermost parts of the earth. Mercilessly, they are shot down at their roosts or nesting grounds. The coveted feathers are stripped from their backs. The carcasses are left to rot, while the young in the nest above are starving. But then, the little bunch of aigrettes on yonder jaunty bonnet is so pretty, so becoming. He's really mad. And we really shot out the birds. And I didn't even notice it until just yesterday. But look at this. This is the end of the great egret one. It is a blot on Florida's history because he wrote a similar rant. The subject will be found by W.E.D. Scott in the Awe. And so what Scott did was he was here after the Civil War, and he went around the South Florida rim, and he documented these colonies of nesting waiting birds, 1 million birds or 2 million or whatever the guess was. And then he went back in the 1880s, and they were gone. They'd all been shot out in just 20 years. And so he documented it. And when he got around to Fort Myers, he heard about Batty. And Batty was shooting birds outside of town. And so he went out to find Joseph Batty, and he sat there and shot with him all day. And they were shooting birds to ship up to New York to make hats and clothes out of. And Batty told him he had 60 people working for him and along the Gulf Rim, and they were all sending him birds. He'd send them to New York. And these guys are making money off this. This is what they were doing for a living. And it was just decimating our birds. And so even before the year 1900, our bird populations have been really seriously harmed. And let's see. Well, okay, yeah, to wrap up the story of Batty, the reason there's a picture of him from the American Museum of Natural History is they ended up hiring him. And they said, you're good at killing things. They sent him to South America, and he was sending back specimens of birds and mammals, and he somehow had a gun accident and apparently killed himself. And so there's a write-up in the Auk about him, and it said, he was a great guy. We realized he was in the unfortunate plume business for a while, but he got out of that and he worked for us. We really liked him. But it's kind of the community of ornithologists back then was very small, and people were on both sides of the fence, and it was just kind of a weird time. And of course, market hunting was going on back then. If you go hunt ducks to feed your family, you just shoot a few and you go home. If you're selling them at the market where people will go every day to buy food, you use these great big guns, and they would kill as many birds as they could at night. So our waterfowl populations also plummeted drastically back that early. And this is this guy's headache gun. He said he took 2 aspirins before and after firing. But anyway, so this massive slaughter of our wildlife. And of course, the bison herds were about gone back then, passenger pigeons. There were just a lot of things. In New England, there were no more turkeys or deer because everybody shot them all. And we were starting to get a social consciousness that, maybe this isn't okay. Maybe we need to have some restraint. Okay, so Audubon. George Bird Grinnell was the editor of Forest and Stream, which now is Field and Stream. And he started an Audubon Society, and he named it after John James Audubon because he was tutored by Audubon's widow when he was a kid. And so he wanted to start a society and send pamphlets out to kids and say, hey, we should appreciate our birds and not kill them. And so anyway, he did that for about 4 years, and he ended up with like 50,000 subscriptions. And he just couldn't keep up with it, and he quit. And it was after that in Massachusetts, some people organized the Massachusetts Audubon Society, and it was a statewide society. And that was really the beginning of Audubon, but it wasn't really the beginning of awareness of protecting birds. Massachusetts passed laws to protect useful birds. Of course, Alexander Wilson wrote a lot about how many caterpillars a chickadee can eat and stuff like that, and it can protect your orchard. They passed laws to protect insectivorous birds. Florida passed a plume law in 1877 before W.E.D. Scott even came back. But these laws were not enforced. These things were really hard to enforce because they used common names. And so if you shot a cardinal and got arrested, you'd say, I didn't shoot a cardinal, I shot a redbird. And they were just cumbersome laws. They didn't really work. And it was in 1886 that the AOU came up with a model bird law. And what they realized was there's only really certain things we hunt. We hunt waterfowl, we hunt the grouse family, bob whites and turkeys and grouse. And then there's a couple other things in there. There's a couple shorebirds, the woodcock, and the snipe. But they said, we're going to say, okay, you can hunt birds for sport, and we're going to restrict it to these game birds, and we're going to have seasons and limits. And if it's not on this list, you cannot shoot it. And that took away a lot of the confusion, because if you shot something that wasn't on the list, you couldn't do it. And so with these Audubon societies, they started forming in different states, and different states would form the Audubon. And so in 1900, the Florida Audubon Society was started. And in 1901, Florida adopts the Audubon model law because we were the ones promoting it. And so all these states had this model law getting adopted, and it wasn't until 1918 that the Migratory Bird Treaty Act was adopted, and then it became kind of a national law. So this was all set up by the AOU and by Audubon. And it's still our basic framework. And so here's Chapman. He did a lot of work. Here's T. Gilbert Pearson. He was the second president of Audubon. And in his memoir, he talks about going around, and he'd go to Florida and he'd get the model bird law passed. He'd introduce it to the legislature. And then he'd go to South Carolina and he'd get it passed. And then he'd go to Massachusetts and he'd get it passed. And I'm thinking, how does he just show up at a legislature and get this law passed? And he was, by his own admission, kind of an awkward type of a person. And I just couldn't understand how he could convince legislators back in those days, especially when people were doing a lot of subsistence shooting, to pass it. Well, one thing he didn't mention: women. This is Clara Domrich. She founded the Florida Audubon Society. You go to Orlando and you can go on Domrich Drive, where she and her husband lived. He was a very wealthy agricultural industrialist. And so it was actually women starting these Audubon societies because they were educated, they were wealthy, they had contacts, they were not encouraged to work, they couldn't vote. So they had a lot of time on their hands. And so if you look at the original board of the Florida Audubon Society, and Leslie is at Rollins College. This is a wonderful book. And if you look at her board, Teddy Roosevelt was an honorary member. The governor of Florida was a member of her first Audubon board, the head of Rollins College. And so anyway, it was a who's who. And what happened is when Pearson would show up in these states, the women had already taken care of. The lobbying was done. And in Pearson's book, he doesn't talk about it at all. It's just like, yeah, I went there and I did that. So anyway, reading her book solved a lot of mysteries for me. And here's a cartoon of Chapman with his women. And this is from the Condor shots of, look at this guy. That's Alfred E. Newman, the Mad Magazine guy. He didn't become Mad Magazine until 1954. This was 1901. They had this image that they had found and they used it. So anyway. So, and then across the pond, the Royal Society for the Protection of Birds was waging kind of the same war. There were birds being brought in from, birds of paradise and all around the world, and they were making hats, and so they were making fun of people. So there's a big PR campaign going on that this is not okay. We shouldn't be doing it. We need to pass laws. And here's the grave of Guy Bradley. He was one of our first wardens. He carried a badge and he got murdered in Florida Bay in 1908. Later that year, Columbus McLeod got murdered in Sarasota County. He worked for us. Presley Reeves got killed in South Carolina. And that really shocked America, that it's bad enough killing birds, but when you kill people who are trying to protect the birds, that's just over the top. And it turned out that in 1917, New York City actually passed a law that prohibited the import of feathers for making hats. And the millinery industry, which was centered there and employed thousands of people and it raised millions of dollars, and they made all the arguments you always hear, you'll put us out of business, it's bad for the economy, but that got paused. And partly it was the abhorrence of killing people, but also partly it was World War One, and wearing fancy frivolous hats was not really in fashion because of the struggles. So all those things came together. But anyway, we finally got the plume business really pretty much shut down. And here's another Chapman book. It's a field guide. You don't have to shoot these birds to identify them. And, you know, revolutionary. And then women, birds through an opera glass. Let's look at them. Let's not shoot them. Mabel Osgood-Wright. This is a very anthropomorphic book. She wrote it with Elliot Cowes, which I can't believe those two linked up like that, but she talks about the virtues of birds and all this stuff, trying to get people to be sympathetic to them. And our Audubon sanctuaries, which I showed you a picture of Marvin, the governor and cabinet actually designated parts of Lake Okeechobee as wildlife sanctuaries, and they're still extant. They're kind of symbolic nowadays, but they're still in the lake. And even the town of Okeechobee supported us. And even up into the 1930s, here's Marvin again. He's behind the Bassinger store. These are all eggs. This guy, Charles Doe, was still collecting, and he was doing it for scientific purposes, but the Chandler family didn't like him. And so what he would do is he'd pay people to get eggs, and then when he'd come by, he'd pay for them, and then he'd go on his way. And he got into a disagreement with some people who offered to kill him if he came back, and he didn't come back. And that's how Marvin found those eggs. But just here's Rod Chandler looking up this cabbage tree. And this is what he's looking at. We think those are Doe's spikes, Caracara tree. And so what the Chandlers would do, and this is in a cabin, it's called Saddle Hammock. And I asked Rod's son where that is, and he doesn't remember, because I would like to see if that tree's still there. But anyway, so what the wardens would do is they'd climb up the tree as soon as the birds laid the eggs, and they'd stamp them property of the National Audubon Society. And that way Doe couldn't go put them in his collection up in Gainesville. But anyway, so this was going on clear into the 30s. And so in Howell's 1932 Florida Bird Life, he talked about the long, unremitting, and finally triumphant struggle. If you think about this, this is 1932, and I was showing you laws from the 1870s. And so this took a couple generations to really get to happen. And nowadays, if you go out and shoot a cardinal, you can count on your neighbor may call the wildlife officer, they'll come write you a citation, you'll go to court and get a punishment. And so our society has accepted this idea it's not okay to kill birds. And it took a long time. So now I'm going to get into the slug that I work on. Oh yeah, and the other thing is, even though I'm going to talk about water from now on, a lot of it is still about birds. Like the snail kite on Lake Okeechobee. Okay, so this is from some anonymous author somewhere. Never mind. So here's the good old days of the Okeechobee watershed, and all the water from Orlando would flow into Okeechobee. It's 100 miles, and then it would all go down to Florida Bay. Some of it apparently did go down the Caloosahatchee. And so the lake always has been the neck of an hourglass. And so all this water would come into here, and then it goes somewhere. It still's that way, and it still makes Okeechobee the most important single water management feature in South Florida. And in the 1920s, 1940s, we had our big hurricanes, and it flooded everything from Miami to Orlando. And we went to the Corps of Engineers. And we've been trying to drain the Everglades already, but these were kind of piecemeal efforts. And we said to the Corps, will you come help us drain our state? And the Corps said, sure. And so that was 1949. And what they did was they took this original system and they said, well, you know, it's a lot easier to get rid of water this way because that's closer than Florida Bay is, and this way. And so they dug big canals to run the water east and west, and the Everglades flows really dropped off. And so nowadays the Everglades gets too little. These guys get way more than they want. And Everglades restoration is about how do we turn this around and put more water back to the Everglades where they need it and quit bombing our estuaries. And so that in a nutshell is what SERP is, the Comprehensive Everglades Restoration Plan, SERP. And, you know, this is just you can see it. Here's people. Here's the Everglades agricultural area. This is all improved pasture. This is kind of native. This is the Brighton Valley or the Brighton Citrus Grove going in. Lots of human impact. And this is the CNSF system. And this is what they designed in the 1940s. It's all the canals and structures and all that. And it's still our water management system. And it's 70 years old. And, let's say you had a car that was a 1940s vintage car. You could get around. You wouldn't have air conditioning. You may not even have a radio. Your tires would be lousy. Probably wouldn't go 70 miles an hour. And that's the water management district we're managing right now. So that's part of the reason we're doing SERP is it's time to update it. And so again, a lot of this that I'm going to talk about is about what do we do with water, but this is about Okeechobee. And here's some eelgrass. That's underwater. That's how clear the water is when the lake is working right. And when it's working right, all these coots are out there feeding on SAV right now. The coots are down here. There's no SAV in the lake right now, and they're not here. Of course, these pretty communities, the crappie fishery, we can catch 1 million crappie out of the lake in a year. It's more than the whole rest of the state combined when it's working. So here's kind of what happened is when we drained the watershed, the Kissimmee Valley used to fill up with water in the summer, and for the next 6 or 8 months, it would slowly bleed into the lake because it didn't have any fast channels. And when you dig a canal, you're building a freeway. You get through the watershed. And so this is the year 2005, and this is Hurricane Wilma, and it comes in. And by the way, these red lines are what we hope the lake stays at. We would rather it never get above 15 or below 12. That's best for the Marth fluctuation. But you can see here we are way up here with Wilma, and that wiped out. Well, I'll show you what it did. But here's the following spring in 2006, and we're dumping water furiously, trying to get ready for the next water season. We're killing the estuaries because they can't take all that water. And then that summer, the lake didn't really go up much, and then it went down, 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 clear to 9 feet. And this dotted line is the water rationing line. And so the farmers and the EAA were only getting 50% of the water that they wanted. And in 2004 and 5, we dumped 6 years worth of water supply for them. 6 years. And the following year, they're in a water shortage. And so they're not happy with this. They're like, this system is screwy. And that's because, once you dump all that water, you don't have any base flow, and then you just drop like a rock. And of course, the farmers are sucking even more water out of the lake. And so this is part of the reason why SERP is supported by everybody, the farmers, the cities, the environmentalists, because when we have these water events, the lake gets too deep, causes problems, it gets too shallow, and we have these issues. And so here's the submerged, well, here's the vegetation. This is all emergent stuff. This is the stuff between 15 feet and 11 feet that we want the water to fluctuate across. The orange areas where our SAVs can grow. And so these are the big plant zones. About 1/3 of the lake can be vegetated when things are working. But here's the SAV. And so in 2005, after Wilma came in, we had 40,000 acres of SAV, think down to 2. So that's like losing 60 square miles of plant communities. And then we had a big drought, and it all came back, and we were clear up to 50,000. And then the lake kept hitting 16 feet every year into this ink. And then Irma and those other storms really knocked it out. And then Tropical Storm Eta. We had really low water here, and it started to grow back. The Tropical Storm Eta knocked it out. And so right now we have functionally no SAV. And that means the bass fisheries tank, the crappie fisheries tank. All these migratory birds are here right now. The lake's over 16 feet, and they can't use it because it's too deep. And so these water problems, we fight about water up here, but it's happening downstream of us. And here's what happened to snail kites. Here's the 2004 and 5 hurricanes. But then what happened is we hit a drought in 2007 and 8. And look at the beginning of this drought, about 1,500 snail kites. By the end of it, there was only 700. That's because when the lake goes dry, there's no habitat for them. So first the Everglades goes dry, they move to the lake goes dry. And then everybody's like, well, where do they go? And we're like, well, we don't know, but half of them end up in heaven. And this first drop was from 3,000 down to about 750. This was during the 2001 drought. And so in a period of about 10 years, we lost 75 to 80% of all the snail kites in the state. This is not okay. And so here's Hurricane Irma. And so Irma came in September, and the lake was, 13 and a half feet, which is not bad. And look at how fast it went up. It went up 3 feet in just 1 month. That's 1.5 million acre feet of water went into Lake Okeechobee. And we blew right by our 15-foot line, got way up here, and it wiped out all our SAV and really caused a lot of trouble. And again, this is that drainage, the water just dumps right into the lake. And so if you look at after Irma, if you look at the hydrograph at Lake Kissimmee right here, and it drains this entire area up here, it's 40% of the watershed. Here's Irma. And look, by December, they're already in a drought. They're below this red line where they want to be. You just had a major hurricane and you're in a drought. You're already out of water. And of course, where'd it go? It went here. And so they would like to keep that water better, and we would like them to keep that water better too. And so this is part of the drainage problem in our watershed is we have way too much drainage and it causes these problems. And again, and I'll mention it more, but when you get 1.5 million acre feet in 1 month, what's your prospect for cleaning that or for filtering it? There's no chance. And so here's a disembodied Kissimmee River floodplain. This is Restored River, but here we are, December 7th, 2017. We just had a hurricane, a major hurricane 2 months before, and all this brown is dry. So the river restoration, it wasn't fully functional back then. It's still not, but anyway, so how can you have a hurricane? How can you have all that blessing of water and already it's gone? Okay, so we have too much drainage. This is 2018, the year after Irma, when the lake got all that water in it. It got a whole bunch of nutrients in it, and it blew it up in raging cyanobacteria. And obviously, we don't want this either. And again, those big flows, we didn't get to clean the water. We carried all the nutrients, and this was the result. And if you go down to Lee County, here's their boat ramp. Says algae alert, stay out of the water. Here's Martin County over on the St. Lucie, high bacteria and blue-green algae, avoid contact. These are on boat ramps. If you're the Chamber of Commerce, this is the last thing you want to have is don't touch the water. It may kill you. Florida makes so much of our economy on the water, from swimming and kayaking and fishing and just, tourism. And to have this happening to our water resources is really not okay. And then you get this. And it's, the lake's a toilet. Those are drain pipes. There's no water going south. Unfortunately, it's a little bit accurate, but it kind of hurts my feeling too, because we have this fabulous lake and this is where we are. And the reason the phosphorus is so bad is this is historic phosphorus levels. And this is the green are the concentration of phosphorus going into the lake back to the 70s and 80s. The blue is the concentration of phosphorus in the lake. And the goal is 40 parts per billion because they started doing nutrient studies back in the 70s when they noticed the lake was changing. And they're like, we think we're polluting the lake. And everybody's like, no, it's okay. But they did their studies and then they said, once we got up to the 50s, we started seeing more and more cyanobacteria. And so the goal is to get down to 40, which we used to be at just a few decades ago. But you can see that as these high inflows have come in, the lake's kind of equilibrating with the inflows. And that's not where we want it. An interesting thing is we had some drought years here and not much phosphorus went in because not much water went in. And the nutrient levels of the water column actually got surprisingly low. So it indicates if we can get lower green dots, we can get lower blue dots. But, this is a problem. And look at how long we've been working on this and just no apparent progress. So if you look at our phosphorus goals, and I don't know if you guys saw the photos of Okeechobee, but just for miles, they would have this kind of stuff. Just mortifying. But we think we can get 140 tons into the lake a year on average. We would get back down to 40 eventually. 105 is inflow and 35 comes from rain and dust. And if you take that 105 metric tons and divide it by the 2.6 million acre watershed, every acre can average 1/10 of a pound of phosphorus runoff to meet that goal. If every acre does 1/10 of 1 pound, and we'll come back to that number. And again, our inflow and outflow concentrations are 40. So with all those high green dots, the Water Management District commissioned a study and said, how much phosphorus have we put out? We've been mucking around this watershed intensively since World War II. And how much have we put out? And the answer turned out to be the estimate of 190,000 metric tons. Now think about our inflow goal. It's 105. And this is how much we have in the watershed. Now we don't know how much of it's mobile because not all the phosphorus goes into the lake. But what they did was they did some estimates on how, depending on how mobile it is, we're averaging about 500-ton years rather than the 100 tons we want. And they think we probably will have these for the next 20 to 50 years. So that's 2 generations. That's your entire careers. And so this is pretty unhappy news. And it means we have a lot of work to do because those algae blooms are fed by these 500-ton years. And if we're going to have them for decades, we've really got a lot of stuff we got to do. I have an exciting job. And everybody says, well, who did this? Well, if you go up to the Kissimmee chain where you have Orlando and Kissimmee, most of the phosphorus imports are urban because that's who's doing it. If you come down here to the southern part of the watershed, where mostly it's agriculture, urban's a pretty small cut, and truck crops and dairies, very intensive agriculture, very small footprint though, and improved pasture. So, when people are trying to find someone to hang, I'm like, look, it's all of us. We got to clean up our cities. We got to clean up our farms. We got to, so don't go throwing rocks. And by the way, the water coming out of here is usually below 100 parts per billion. And when it gets to the lake, it's like 200 to 300. So most of that nutrients is being added down here. Okay, so what do we got to do? We got to clean the nutrients. We got to store a whole lot more water in order to get a shot at the nutrients. And we got to convey the water south to the Everglades if we can get it clean enough to put in the Everglades. And quit dumping it down the estuaries. And so this is, these are the goals of SERP, is how do we do this? And Mac, when he took this picture, this was a trap. He'd set this snail out. And Fish and Wildlife Service came to him and said, "You're harassing kites." So he's like, "No, I'm not. I just put a snail out. I just sat there." But actually, this is a camera trap, no less. So if you go down to the Everglades agricultural area and the Everglades, and their phosphorus goal is 10 parts per billion, not 40, this area is about 600,000 or 700,000 acres. And what we've done to protect the Everglades from them is these are STAs, stormwater treatment areas, the big filter marshes. And this is like a very deep reservoir. So when it rains down here, these guys get to put all their water in these water holding features. And then the water is slowly bled through these STAs to get cleaned as it goes. And so we can protect the water quality of the water conservation areas and the hydrology because we have these big buffers of reservoirs and filter marsh. And remember, not much water is coming out of Okeechobee because these guys get priority for all these features. It's kind of a bottleneck in the system. But with this bottleneck, they have all these STAs. And this thing's like 17,000 acres. That's 25 square miles. Really, really big features. You just can't believe how big they are. And so that works down there. This is Everglades. They also did some BMPs, and basically what they did was they had these guys quit pumping so much water, and it reduced their nutrient outflows by 50%. Water management is nutrient management. So for the Everglades and the Everglades restoration program, it's really pretty successful approach to build these big box things. They're also building storage north, south, and east. They're all out of proportion, but this is a great big reservoir that's over on the Caloosahatchee, and they're going to try to catch local runoff and prevent it from gushing into the estuary. This is going toward the St. Lucie. They're going to try to, this is a big reservoir and filter marsh system where they can catch the water and clean it and then move it on. And then they were looking at reservoirs up here. And so if you look at all the SERP spending, it was $8 million. We were only going to spend about half of 500 million up here. And the other 7.5 billion was going to be spent around the lake and southward. So we were getting 1/16 of all the funding envisioned in Everglades restoration, north of the lake. Remember, the north of the lake is 2.6 million acres and the Everglades 3, and we're getting 1/16. So, and I talked to some of the guys that worked on the restudy. I didn't work on it, and they didn't really realize how many issues we had up here. And the focus was really on the Everglades. And at the last minute, they just went to some of the Okeechobee guys and said, if you had $500 million, what would you do? And they said, we'd build some Rastas. Well, it turns out that this rapid runoff, the Hurricane Irma, where 1.5 million acre-feet of water runs by here, you can't pump enough water into your reservoir to keep your STA wet for the whole dry season. And if the STA dries out, then the material in the bottom oxidizes, the nutrients get released, and they just come right back out. And so building reservoirs up here has not been, building a reservoir and a filter marsh hasn't worked because our watershed's so flashy. And the further down you get in the watershed, if you're down here, you've got flows coming out of the lake or over here or down in the EAA. But the higher up you go in a watershed, the flashier it is. And so this big box approach doesn't work up here. And the other thing that doesn't work up here is this is on an abandoned citrus grove, abandoned sugarcane lands. And so they've already been very heavily impacted. There's hardly any biological value left in them, and nobody sweats any bullets about putting those under 12 feet of water. But when you come up here, whoa, and here's one of those features. This is the C44. This one's only 3,400 acres. Look at this wall. It just disappears into the distance. These things are like miles across. And they cost $1 billion, and they take 10 years to build because they're just so massive. And so they're helpful down there, but up here, they don't work right. And also, when you put one of these up here, you're covering up caracara habitat, you're covering up grasslands and wetlands and habitat that actually we don't necessarily want to lose. And, for people who live up here, we don't want the development to help somebody else down there. We get the blight and they get the benefit. So this has been problematic for what do we do north of Okeechobee because we have these problems. So in 2007, we wrote a report. This is still on our webpage somewhere. And we're like, SERP is only going to store about 250,000 acre-feet of water north of the lake. And we're like, we don't think that's enough. When you got 1.5 million that'll go in the lake in a month, and after Faye, we got 2 million in a month, and after Ian, we got 2 million in 2 months. But we're going to need a lot more storage to try to catch that water long enough to be able to clean it, and also to keep the lake from going by and starting that cascade of bad events. And at the time, there are some people who were pretty pissed at us for saying that. But we got a favorable administration in, and they said, you know what, you're probably right. And so the district has changed the storage goal north of the lake. Now it's 900,000 to 1.3 million. That's the goal. This is the 23 environmental report. But look at how far we are toward reaching our goal. So long way to go. And this is a lot of DWM projects. We've got them on Buck Island. And they're good, they're great, but we need to do like 100 of them rather than 10 of them. And the water year last year, 285 tons. That was a relatively dry year, but it's still way above our 140 goal. Our SAV goal, we want more than 35,000 acres. I want more than 40, but anyway, 3,000, and it's actually lower than that now. And then, of course, the phosphorus concentration in the middle of the lake, we want it to be 40, it's 140. So we're not coming very close to where we want to get. And this gets back to why I talked about the birds and how long it took. Because these are big problems. They're going to take a long time to fix. Okay, so here we are back to this. So here's my career. So that's why I'm telling you it takes a long time, because I haven't gotten anywhere. But anyway, so we've got these really high flows. And what's the nature of why this just stays here and stays here and stays here? So most of the nutrients going into Okeechobee are from agriculture. And so we've gone to agriculture and said, you got to change your ways. And so we do BMPs, best management practices. And best management practices are governed by agronomic rates. When you put out nutrients, you got to do it according to an agronomic rate. And the agronomic rate is the number of pounds of fertilizer needed by the crop being grown. And so this is geared toward what you're growing. And so I got a little vignette. I was at the Water Resource Advisory Commission, and that's a group that the Water Management District assembled, and it's made up of stakeholder groups, so utilities, agriculture, the environmentalists, local governments, the tribes, sister agencies, and they run ideas by you. And a lot of times they run an idea by you that the next week the governing board's going to hear about, just so they can try to spot fires and stuff like that, or get good ideas. And so anyway, we had a professor from the Department of Environmental Horticulture at the University of Florida come and talk to us, and he was talking about their latest urban turf grass recommendation for phosphorus and nitrogen. And urban turf grass, of course, is your lawn or a golf course. And so he's like, this is really environmentally friendly. It's the latest science and it's really good stuff. And it's environmentally friendly. And so, and what it boils down to is when you fertilize, you do soil and tissue tests and stuff. But the bottom line is the default number was about 10 pounds of phosphorus an acre. Remember when I talked about the average for the watershed is 1/10 of a pound per acre, ideally. And so this is 100 times higher than it. So going, and I'm like, okay, why is this environmentally friendly? And he goes, because it's 1/3 of what we used to recommend. Well, yeah, it's right direction. But I'm like, well, do you know what the TMDL, the phosphorus goal is for the lake? And he's like, nope. And I'm like, well, it's, ideally we'd get 1/10 of a pound per acre, and you're recommending something 100 times that high. And he's like, well, this is better than it used to be. And so when he says it's the latest science, it's the latest science on crop growth. And that's the agronomic rate. We're putting out what the crop needs. We're not putting out what our water quality goal is. And so as a scientist working with a policy team, they're like, what do we do about phosphorus? Well, the obvious answer is this isn't working. It's not going to work. It's never going to work. And so tell them to quit fertilizing. But we can't do that because then it would put them out of business. And we don't have fertilizer systems that are pollution free. And most of the agronomic work that's done, like the turf grass stuff, it's paid for by the industry. They're trying to sell a product. And so we met with him later to talk offline. And I'm like, why don't you guys take water quality measurements? Because I'm like, what's your water quality result? And he goes, well, we don't know. And he's like, look, they don't want to pay for it. It costs money. And also water quality's, depending on what part of Florida you're in and what soils, it's really variable. And even on the same site, you can take a water quality sample in May and in September, and they'll be very different. We've learned that on the exact same spot. And so they're just like, we don't do it. But then what we have is we have all of our agricultural research and all the stuff that we're telling our farmers to do. It's not linked to our water quality goals. And we know a priori that it's a problem. And so that 190,000 metric tons that we think is in the watershed as of 2010, I backdated it because every 10 years I'll do a report and say how much nutrients are we importing. And when I backdated it, like the swim plan was passed in 1989, and according to this, the legacy load may have only been 100,000 metric tons, and now we're up to 200,000. And I made this little graph in 2010. I don't know where we are now. So at the same time, we hope we get better and better phosphorus flows going into Lake Okeechobee. Here's what our watershed's doing. This requires a change of thinking. We have to take nutrients seriously. And just like people used to shoot birds and not think about it, well, right now we're still doing what we do and polluting and not thinking about it. And we can't change this until we get IFAS and other researchers to start giving us models that say, here, you can keep farming. We did a very best available technology on the Butler dairies, and they completely surrounded the dairy in a dike, and they built a reservoir. And whenever it rained, they would pump their water in the reservoir, and then they would reuse it when they needed it, and they had no runoff. And so here they are, a high intensity operation. They could do it. And they even had an alum treatment in case they had a major storm event. But they said they even contained all of phase rain, which was 10 to 12 inches. So we can do it, but it costs $4 million per dairy, and nobody wanted to pay for it. It's like, well, and that's where policy comes in, so we know how to do these things, but how do you do them? How do you get the funding? How do you convince people that this is that important? And that's where that science and policy, the science is the easy part. It's easy to see that this is the concern. How do you fix it is a hard thing. And so that's a lot of what I spend time with my policy team saying, well, this is easy. They're like, no, we can't do it that way. And so that's kind of been my job. I didn't know I was going into politics, but I ended up there. And so again, it's not just farms. Once you have a neighborhood built like this, what do you have to do with water remediation here? There's nowhere to do it. On the dairy, we had a place where we could put a reservoir, and they're professional water managers. I mean, they're agricultural people. So, you know, Mark Raines, the governor's chief science officer, he's like, look, if it's an agricultural water problem, we can fix it. They've got space. We can figure out stuff. We may not know now, but we can figure it out. But once you build this, this is a mess. And if it has runoff problems, we're in trouble. And so there's a statewide stormwater rule that I worked on before 2010. And it was trying to figure out, okay, when you build your next development, let's not build something this dense that's not going to have options. And so we want more water retention. Now, of course, if you're the developer, that's bigger ponds and fewer houses. So you don't like that. Impervious surfaces, you know, all the water that lands in these streets and roofs just runs right into the drain pipes and they go right into the receiving water body. You want to have the water percolate. Low impact development, like this building here, where your parking lots are rock, not impervious. And then we want monitoring. You know, it's fine to do your calculations of we're going to build this thing and it'll be fine. But how many times have we gone wrong with that? And anyway, so this got blocked in the legislature. We couldn't get it passed because people didn't want these restrictions. So they reconvened the committee about 3 years ago. We went through the whole process again, and we have another rule which is updated, and it's not everything we want, but it's better than what we have. And we're trying to get it through the legislature this year, and we're having trouble because people are blocking it. And that gets back to, is our society aware enough of the need to do these things to where we're going to start doing it? And this gets back to the birds. You know, we've got to write articles and talk to people and all that. So in the meantime, we're doing projects. This is Alapata Flats. This is part of the Indian River Lagoon project. And, you know, this is not rocket science. I just plug the ditches, and when it rains, this water sits here and it percolates through the sand, and it doesn't rush down to the estuary and cause pollution. These types of things are really easy to do. We know how to do it, but we've got to get more funding and more support for doing it. The Simi River Canal. This restoration was done for environmental purposes. It was done to restore the ecology of the river because everybody realized what we'd lost. And you can see the remnant canal right there. And even though this is an ecological restoration project, how fast is the water going? Is it getting filtered? This is meeting our water management goals in an ecological way. And we need to do this all across our watershed. And if you build it, they come. And, you know, this is the old way we did citrus, kind of like that urban development. There's nowhere for water to sit. It runs right off. This is the Brighton citrus grove for Likes Brothers. Joe Collins helped design this. And so we're growing food for people in large amounts, but we're not wiping out all the water infrastructure. When I talked to Joe about this, he's like, well, we learned that you can drain that pond, but when it rains, it's still a low spot. The water goes to it and your citrus gets impacted. So why fight it? And so, you know, we have to start thinking about this when we build agricultural developments and urban developments. And, you know, there's inklings that we're doing this, but we're not doing it on the scale we need to yet. And just, you know, working lands for birds and water. And I quote in this room, that's something you all know about. And the NRCS is already kind of doing this. They have wetland reserve programs. They have grassland reserve programs. They have programs to go to landowners and say, can we get you to hold that water? And we'll pay you. You know, we can pay to build a reservoir, or we can pay you to help us with our water management needs. And especially, as Hillary said, most of this watershed is private lands. And if we want to significantly change how our hydrology works, we're going to have to work with the people that own the land. And so this is something that I think is getting acceptance, and I think people are trying to do it. We've got a long way to go because there's just such big problems, but this is my hope for the future, is that we start making this watershed green and blue and it doesn't turn into rooftops. And we have a better future. So SERP is great, but it's focused mostly downstream. The big box SERP projects don't work well up here. We still need large amounts of storage. The nutrients are still increasing. We need more support from society to say, hey, we got to change. And this is going to take a long time. And so with that, this is one of Birds Off Buck Island Ranch. It was abandoned in 2008, and she's been living up on Scrub Pens Road by my office. I haven't seen her for about a year. I'm nervous about her, but anyway, I want a future where these guys can live here, and we can do it with projects. So that's what I got. And that was like one of the weirdest talks I've ever given.
Now, then we can go over and take some in the hallway.
I do have one question online.
Okay, so I'll take one question from the room. Sahas, why don't you start? Oh, sorry, I'm sorry.
Thanks, Paul, for an awesome talk. I was just wondering, how, have there been any restoration of the old populations of birds for water birds other than snail kites? Like, where are we with regards to them coming back, or have they come back now that the hunting pressure is low?
Yeah, so with wading birds, they were almost gone by 1900, and we finally got protections, and they actually rebounded. And by 1940s, there was a nesting colony of white ibises that was like supposed to be 500,000 birds, and but then we drained the Everglades. Back down they went. And waterfowl right now are doing real well. We Farm Bill, and I mentioned NRCS. There's these wetland reserve programs. So we're restoring wetlands in the prairie pothole region, and their populations have rebounded. And again, we have some successes, but we got a lot more to do.
Thank you.
I was curious about the low car project, the storage north of the lake. Is that one of those big box projects that you were talking about, or is that a different approach? And are you on Audubon involved in that? And where do you see that going?
Thank you. I was trying to not talk about that. Yeah, it is a big box project. Their goal is to store 200,000 acre feet of water. And, when I showed that 1 million acre goal and we're up to 67, it would really do a lot in a hurry. We want to restore as many wetlands as we can, but we can't restore them all. So building that does get you a lot of water storage in a small footprint. They want to make it 21 feet deep, which makes the footprint smaller. But it will take out territories. And so we support it. But we really are not going to get to 1 million doing that kind of stuff. That's just not what we want to do. But a few projects like that, strategically located, can be helpful. So
I'm gonna do 2 more questions. Laura's going to read one from online. Okay.
All right, we have one from Josh online. What caused the phosphorus in the lake to rise 2005 to 2009 and then decrease 2009 to 2015?
okay, I didn't quite understand that.
So I think it was looking at phosphorus, maybe concentrations in the lake that rose 2005 to 2009 and then went down again 2009 to 2015.
Okay.
On the graph you showed.
On the graph you showed.
Yeah. So we switch back and forth between loads and concentrations.
Yeah.
I'm sorry about that. But when you get low rainfall years, you don't get very much phosphorus running in the lake, and so water quality has a chance to do better. And when you get high rainfall years, you get more water nutrients, and so those ups and downs basically are how wet the years were on average. So, and again, that's not us being better managers. If it's a dry year, we just get lower results. And again, that period in 2010 and 11, when it got down clear near 100, one of the theories was there's so much mud and nutrients already in the lake that it'll never get down. And that showed that if we can reduce the inflows, it can respond. So that gives me hope. And once we figure out what we're doing up here, we can make progress. And they're also talking about dredging the mud out of the lake. And if we did that, we could kind of start over. And that's probably something we need to do. It only costs $3 billion.
Thank you. That was a really good talk. Just soaking up all the information. So you mentioned that we have 67,000 acre feet of storage north of the lake, but how does that account for the Kissimmee River storage and all the other DWM projects?
Yeah, that's a good question. They don't count the Kissimmee River storage in that figure. So the Kissimmee River storage, we think gets about 100,000 acres of static storage at a time. And since it's a pre-SERP project, they count it as an existing condition rather than new storage, which I think we should count as new storage, but whatever. But yeah, it's a big help. And we're going to raise the Kissimmee chain of lakes up another 1.5 feet, Kissimmee, Cypress, and Hatchnahaw. So that's going to restore a bunch of wetlands up there in the Gardner Cotton Marsh. And then that extra water will help keep the river wet during the dry season. And again, rather than having all that water get in the lake the same month of the hurricane, we're going to bleed it into the lake over the course of the dry season.
So I'm going to be fair to the folks online. There were two, since they can't drink beer with us afterwards. So there's a question from John Fitzpatrick. He just says, great talk, Paul. Wonderful to start with the ornithological and early conservation history as an analogy. What's the current status of snail kites after the introduction of the new apple snail?
Yeah, that's a whole nother talk, but
I agree.
yeah, so what happened is they went from 3,000 down to 700, and then the exotic snails got loose in about 2008, right when we hit that bottom, and they spread through the Kissimmee chain, and they spread all the way down to Okeechobee, and now they're all across Florida. And so the snail kite population is now rebounded up to about 3,000. Fortunately, they've done that, but it's almost all of the exotic snails, and they're not living off the native snails. And also, snail kites are not nesting successfully in the Everglades. And when your indicator bird can't nest in your wetland system, then and we don't really know what's wrong with the native snails down there. We're trying to find that out. So the good news is their numbers are good. The bad news is they're not good for the reasons we wish.
And then one last question. This is from Emily Anderson. And she's asking what percentage of the Northern Everglades Basin has water retention projects? It's actually quite a difficult question because there's natural retention. I think she means new added, and I think she means area, not acre feet.
Yeah,
I
so
could be wrong.
I'm going to have to kind of estimate this, but that's 67,000 acres.
Right.
That would probably be like 50,000 acres of area, something like that. And so, and 50,000 acres out of 2.6 million, we've got a lot more potential to try to fulfill. So, yeah, and again, these are new projects, and Archibald and Buck Island Ranch have been helping to pioneer them. They helped do some of the first experimental ones back when we had the Florida Ranchlands Environmental Services. And so the agencies have done them. Now they've learned how to monitor them. And so I think if we can get that support to scale them up, really start working with people, we can start doing a lot more of them. And again, NRCS money can help do it. The refuge concepts, we can buy land and restore wetlands on them. And so there's a lot of different vehicles we can try to use to try to rehydrate this watershed to the extent we can.
Okay,
And
so
rehydrating the watershed also helps fill in corridor pathways.
yes.
So there's a good synergy there.
Okay, well, thank you again, Paul. We really appreciate it. Yeah.